Okay, I think when I went over the page 295 assignment, I think I forgot to zoom in on the screen. Sorry about that. Hope you can still read it okay. All right, welcome to section 7.2, new material. Again, in case you didn't watch that previous section, just want to mention two things. One is I'm switching over to VGA to try to make my files smaller, to make them upload to YouTube faster, because it's been taking about an hour to upload each video onto YouTube. So I'm hoping this will help. If the quality has degraded to the point where you can't read the screen, then please let me know and I'll switch back, but I'm hoping I don't have to. Another thing, so we're going to start something new today. I've done it with my geometry class, and I'm about to do it with all the others. I'm going to start introducing quizzes built into the video. This is to help encourage you to actually watch the videos, because if you don't watch the video, you won't know what the quiz questions are. So I'm just afraid some folks might be jumping to the assignment and not bothering to watch the video. So some of the videos, not all of them, some of them, if I remember to do it, will include a simple 4-question quiz. Oh, you always say it's simple. No, I'm talking really simple. And here's how I want you to do this. Just jot down the answers as you go, and when we're done, then you will send me an email. And folks, some of you have not been following my email guidelines, and it's very frustrating. In the subject line, always tell me your subject and section to A or to B. Give me your subject and section, Algebra 2A or Algebra 2B. Then comma. Then write for the quizzes, write the word quiz, and this quiz will be the quiz based on section 7.2. So Algebra 2A, quiz 7-2, or Algebra 2B, quiz 7-2. All right? Then you will enter your 4 answers, not on paper. You're not going to do it on paper and take a picture and send the picture. No. Way too much trouble for both you and especially for me. I don't want to have to open your pictures for this one. For the quizzes, I simply want you to do something like this. In the body of your email, not as a picture, but just in the regular body of the email, you will type in number 1 and the answer, 2, the answer, 3, the answer, 4, the answer, and send that to me in the body of the email, not as a picture, not as an attachment. And you'll get 4 points. It should be free 4 points, because the questions will be things like this. I'm going to give you question number 1 right now. Are you ready? Have to work hard at this. This one's a tough one. And I'm serious. I'm not joking. Question number 1 for your first online quiz is this. What number is now in yellow? So question number 1, the answer is 1. You'll simply put a 1 there for the answer to question number 1. See how easy this is? It's just to make sure that you're actually watching. So that's how this works. So write that down. That is really the first answer to the first quiz question, okay? 1. Write it down someplace you don't forget. What did you say? Was it a 1 or a 2? It's a 1, okay? All right, now we move on. First concept in section 7.2 is this. If I say square root of 4 times square root of 25, well, that's easy enough. Square root of 4 is 2. Let's put it down here by the dot. Times. Square root of 25 is 5. I think we pull out the calculator if you have to, we get an answer of 10. Now, what if, on the other hand, will that be the same thing as taking the square root of 4 times 25? Just taking these 2 square roots and kind of putting them together into 1. Well, square root of 4 times 25 is going to be the square root of 100. How about that? It is 10. They are equal. 10 equals 10. So the moral of the story is very simple. When multiplying, not when adding, it doesn't work with addition, but when multiplying radicals, you can combine them into a single radical by just multiplying. And it works just as well. The rule, as stated in the box, theorem 7.4 at the top of page 297, says that the kth root of A, and it doesn't matter what the index is, that's why we use a k there, because it could be a square root, cube root, fourth root, it doesn't matter, times the kth root of B. The point here is that the indexes must be the same. The kth root of A times the kth root of B will be equal to the kth root of, just multiply, A times B. You can simply put them together. That's it. But only when multiplying, not when adding. So, example 1 on page 297 says, what do we get with the square root of x plus 2 times the square root of x minus 2? Oh, well, that's going to be the square root of x plus 2 times x minus 2. Now, the reason they gave you this particular combination is because they really are, and I really am, expecting you to change it to square root of what? Yeah, you know how to do these. X squared minus 4, and we're done. Oh, something just popped into my mind. Folks, this is a negative sign. Because this is a negative sign, you cannot rip that apart. You cannot claim, oh, isn't that just going to be x minus 2? The square root of x squared is x, and the square root of 4 is 2. Isn't it just x minus 2? No, it is not. Because is x minus 2 squared equal to this? Of course not. No, it doesn't work. No, because of that minus sign, you can't split these apart that way. Therefore, at this point, you are done. There's nothing else to do to it. You are done. Let's move on to the next example. Example 2 goes like this. Cubed root of 4 times the cubed root of 5. Well, the rule says that since the indices are the same, is it indices or indexes in this context? I don't know. Since this index is the same as that index, that's a clever way to say it, avoiding the plural. If this index is the same as that index, then I can combine them under one radical and just write 4 times 5. Of course, we all know 4 times 5 is just 20. We get cubed root of 20. Done. Moving on to the next example. That next example is not worth, well, I guess we better look at it. I don't want to skip too much stuff. If you don't need this example, just fast forward. How about fourth root of y over 5 times the fourth root of 7 over x? Mr. Beer? Yes? Didn't you leave out the multiplication dot? I don't need a multiplication dot. No more than I need one here. If there's no operator in between, it always means multiply, of course. So, multiplying these guys, we get what? Fourth root of y over 5 times 7 over x. You can skip this step, which gives you fourth root of 7y over 5x. And we're done. Make sure you've simplified the fraction, but there's nothing to reduce here, so you're done. Fourth root of 7y over 5x. Okay, there's some try these problems. Hey, in case I haven't mentioned it before, I know I've told you guys in class many times in the past, but anytime you come across the try this problems in the book, yes, you really should be following in your book. You should be open to page 297. On 297, right in the middle of the page, you see 4 try this problems. What's nice about the try this problems? Yeah, you remember, the answers are all in the back of the book. So you can try this by doing those 4 problems and check yourself in the back. Let's see, let's go on to this concept. Yes. This is something that those of you who had me in geometry last year, that doesn't look good, that's better. Those of you who had me in geometry went through this process just last year, or whatever year it was you had geometry with me. Square root of 20. That is not simplified. We have to simplify the square root of 20. So the next question obviously is, how does one simplify the square root of 20? Here's the trick. First, someplace, either in the back of the mind or preferably in the front of the mind, you have a list of perfect squares. What's meant by perfect squares? Well, 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared, 36. 49. 64. 81. 100. What's 11 squared? You're supposed to know that one. Yep, 121. 12 squared? Yeah, I heard that. 144. There's a trick for 13 squared and 14 squared. They're very easy to remember if you notice this trick. 13 squared happens to be 169, and 14 squared, take these digits and reverse them, you get 196. That makes it easy to remember. So that's 12 squared, 13 squared, 14 squared, 15 squared is 225. And we're going to stop right there. We don't need to go any farther than that. We look at these perfect squares in our head, or if you insist, on your paper. And by the way, if you want to put them on paper, when I send you the test, and your parent is proctoring the test, of course, you write these down after you receive the test paper, not before. But you should have them in your head anyway. You should not need to write these down. You ask yourself, which of these numbers divides evenly into 20? Well, pretty clearly it's going to be 4. 20 can become square root of 4 times 5. Why do we care? Well, because I can split this into square root of 4 times square root of 5, right? That's the reverse of the rule that we just looked at a couple minutes ago. But I know the square root of 4. Since I know the square root of 4, I just change it to a 2. I don't know the square root of 5. It's a perfectly good number, but it happens to be irrational, so I simply leave it as square root of 5. And we have simplified square root of 20. But Mr. Bear, this looks simpler than that. Well, true, I would agree that this looks a little simpler than that, but the concept is simply this. A radical is not simplified until any square roots that you can take out have been taken out. There was a 4 buried inside that 20. I had to take out the 4, and it became a 2. Now, there is a special word here. This is a peer word. It's going into my peer dictionary that I'm never going to write. Or when I write my math book that I'm never going to write, it'll go in that book as well. And that is this. When that 4 pops out, it makes a sound. It breaks through that radical sign and goes pa-ching! And as it makes a landing outside here, it turns into its own square root. So that square root of 4 goes pa-ching! Pops out and becomes a 2. By the way, the correct spelling of that is pa-ching! And the only correct way to pronounce it is pa-ching! So the 4 pa-chings out and becomes a 2. You're left with the 5 because the 5 is not the right shape to come out. A couple more examples of how that works. Let's consider the square root of 75. All right, what perfect... Oh, I erased my perfect squares. Well, imagine that list is still there. Oh, let's not just imagine. 4, 9, 16, 25, 36, 49, and I'll stop there. What perfect square goes into 75? You are absolutely right. 25, that's a 2. 25 goes evenly into 75. So here's this easy way to do this in the head. Or perhaps by doing a little work on your paper, you say to yourself, what square goes into 75? 25 does. So we're going to either in our heads or on paper change that 75 into a 3 times 25. Then the one that you know the square root of, pa-chings out. Because I know the square root of 25 is 5, the 25 goes pa-ching, pops out, becomes a 5 on the outside, and we're left on the inside with that poor 3. He's stuck inside. He's not a perfect square. He's not allowed to come out. He's trapped under the radical. That's just the way it is, and you've got your final answer, 5 square root of 3. We pachinged out the 25. And I said the only way to pronounce it was paching, and now I'm saying paching. Sorry about that. One more example. How about the square root of 288? At first glance, it might look a little bit tricky or hard. Oh, the number's too big. Wait a minute. How about an old favorite square? 12 squared is 144. 12 squared is 144. 144 comes out. It's simply 144 times 2. But then because, again, we know the square root of 144, the 144 goes pa-ching, pops out, becomes a 12. 12 square root of, oh, that poor 2 has to stay inside. Yes, he does. By the way, if you ever had a reason to, you can reverse this. You could put the 12 back inside, but when it goes back inside, it unpachings. Unpachings. How would you spell that backwards? Gnickepek. 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 It gnickpecks. It pachings backwards. Gnickpek. You put it inside, it would turn into a 144. 144 times 2 would be back to the 288. I think that's the first time in my life I've ever said gnickpek. All right. We're going to leave that concept behind for now. See if there are any really clever examples they have here. Okay, well, one more here. They give us this as an example, square root of 50. Square root of 50 in your head probably becomes square root of 2 times 25. The 25 pachings, pops out, becomes a 5, and the 2 is left inside. See how easy it is? All right. What about a cubed root, though? It's a little bit different. Cubed root of 32. Well, for the cubed root of 32, we want to take out not perfect squares, but we want to take out perfect cubes. Ooh. What are the perfect cubes? Well, 2 cubed is 8. That's right there. 2 cubed is 8. 3 cubed happens to be 27. What's 4 cubed? We saw that earlier today, or maybe that was in the review assignment. It turns out to be 64. 5 cubed is 125. 6 cubed I can never remember, and I don't really care because you're not likely to need anything higher than 125. So we want to know, are there any perfect cubes that will go evenly into 32? And of course, yes. 8 goes evenly into 32. So that 32 can become 4 times 8. Why do we care? We care because we know the cubed root of 8. How about that? Because we know the cubed root of 8, the 8 can pop out. What is the cubed root of 8? 2 times 2 times 2. It's 2. That feels funny, doing this and saying, it's 2. Each of these fingers is a 2. 2 times 2 times 2. So the cubed root of 8 is 2. 8 goes pops out, becomes a 2. Inside, we're left with that poor 4. Well, can't we take out the 4? I know the square root of 4. Yeah, so do I. But this is not a square root, it's a cubed root. We don't know the cubed root of 4. It's irrational. So we're stuck with the 4 inside because he's not a perfect cube. I don't see him in this list. So we're stuck with the 4 inside. The 8 pachinged out, became a 2. Done. And there's one more worthy example here. How about square root of 2x squared? 2x squared minus 4x plus 2. 4x plus 2. Oh, I see what they're doing with this one. Remember, I know that this is before the days of the video, back before the Corona days. We talked about something I referred to as step -1. Step -1 is that step that you do before you do step 0. Step 0 is the thing you do before you really get started. But step -1 is take something out of all 3 terms. Remember that? Oh yes, of course we remember. So we take out the 2, we're left with x squared minus 2x plus 1. Guess what this is? Yes, it passes the RAP test. What was squared? What was squared? Multiply and double. What was squared? What was squared? multiply, and double. Do we get the middle term? Yes, we do. So this whole thing becomes square root of 2 times what? What was squared? X. What was squared? 1. Match the sign. Don't forget your exponent. And we're practically done. Now we have what? Now we have, well, we know the square root of x minus 1 squared. So it pa-chings out. Pa-ching! And we're left with the 2 inside. What mistake did I just make? On purpose. Well, first of all, the parentheses, you can't just do this. If you do that, only the 1 is being multiplied by the square root of 2. We don't want just the 1 multiplied by the square root of 2. And I've caught some of you neglecting your parentheses, but that's still wrong. Because this is an even index, the invisible 2. When using an even index and we've got a variable involved, we have to take the absolute value of x minus 1. So our final result is absolute value of x minus 1 times the square root of 2. And it's over. All right, we have a little bit more to worry about here. Consider example 7 on page 298. Square root of 15 times square root of 6. All right. There are a couple ways of going about this. We could simply multiply 6 times 15. 6 times 15, well, 6 times 10 is 60. 6 times 5 is 30. Put them together, that would be the square root of 90. Now, I would dare suggest it doesn't take too much thinking to recognize what square goes evenly into 90. What square goes evenly into 90? Yeah. 9 times 10. Oh, that was too easy. I just didn't see it. Yeah, I know. Sometimes the easy stuff just slips us by. But we know the square root of 9, so it pa-chings out, becomes a 3 on the outside, and inside we're stuck with that 10 that can't go anywhere. We're done. But there's an alternate approach I want to show you. In this case, I think that was the easiest way, but there is an alternate approach. How about if we factor 15 and write it as 3 times 5? And then we factor the 6, write it as 3 times 2. Now, a lot of this work we would do in our head, but this would become square root of 3 times 3 times 5 times 2, putting it all together. But is not 3 times 3 the same thing as 3 squared? So doesn't that mean that the square root of 3 squared, wouldn't the 3 then pa-ching out? Because we know the square root of 3 squared is just plain 3. And we're left inside with 5 times 2. Let's change that to a 10. And lo and behold, we get the same answer we got before. There are times when this is actually the easier way. To factor this guy and factor that guy, and then put things together and see if you have any squares. This works much more nicely if your numbers are big. And you don't want to mess with the big numbers. If you factor first, then you can pull out any squares that you find inside. So let's take a look at a better example of this. How about 3 times the cubed root of 25? Actually, this is not that great an example because this one is quite easy to do by the other way. What do I mean by the other way? Well, first of all, don't forget, 3 times 2, guess what 3 times 2 is? 3 times 2 is still 6. We're not changing the old rules. Then we have 25 times 5. 25 times 5 is 125. And yes, we do happen to know the cube root of 125. It's exactly 5. Because 5 times 5 times 5 is 125. So this becomes 5. 5 times the old 6 gives us a final result of 30. But what the book writers want you to see is this. The book writers want you to get to that answer of 30 by thinking it through a different way for practice. And that would be, consider this to be the 3 times the cube root of 5 squared times 2 cube root of 5. And then perhaps in your head, or on paper, you change this to 3 times 2 is 6 cubed root of, what's 5 squared times 5? that's just 5 cubed, right? Uh-huh. And what's the cube root of 5 cubed? Oh, I see, it's 5. 5 times 6. Yep. Same result. Again, there are cases where this method would be easier if the numbers get big. These numbers are kind of small, so it's not a great example. But I think they're going to hit us with a better example. Well, maybe not. Just another example that's also not terribly challenging. Third root, cubed root of 18. Let's make that look better. 18y cubed. And we're going to multiply by the cubed root of 4x squared. Again, take note, we don't need the multiplication dot because if there's no operation between these radical signs, then we know it's all automatically multiplication, as always. So here, let's factor this guy. If we factor this guy, we get 2 times 9, or 2 times 3 squared, right? 2 times 9, 18, y cubed. Here, factoring this guy, we get cubed root of 2 squared, x squared. Now let's put the two together. Again, much of what I'm doing here you would probably have done in your head, not on paper, but not all of it. You take too many shortcuts, and I'm going to assume that you're getting your answers from alternate sources. Yeah, I need to see some steps here. But all of these steps, not necessary. Here I've got 2 times 2 squared is 2 to the third. Oh, look, yeah. And here I've got 3 squared, but that's the only 3 I have. 3 squared. And I've got y to the third times x to the second. Not much I can do with that. Y to the third, x to the second. Mr. Pear, why is it that you used a dot there, but you didn't use a dot here or here? Well, in dealing with variables, the dots are just totally unnecessary. But when dealing with numbers, we just have to make sure that someone doesn't think that we're trying to write 23. I know the exponents kind of separate things out, but we like to have dots between numbers. But we don't need them between variables. So anyway, moving on. Now that I've written my 2 to the third, and my 3 squared, and my y cubed and my x squared, now I say, hey, I've got some cubes I can take out. Because we know the cubed root of 2 cubed is 2. We know the cubed root of y cubed is y. Unfortunately, we do not know the cubed root of 3 squared, so we'll simply put a 9 in there. And we do not know the cubed root of x squared, so we'll just leave that inside. These guys are not cubes, they cannot come out. But the 2 did come out, and the y did come out. We're done. What about absolute value? Oh, you dare not suggest that. This is an odd index. No absolute value. And that's the last example in the book. There's some more try these questions you'll want to try out on your own. And that is it. Your assignment, oh, you know something? I totally forgot to give you any more quiz questions. So I need to throw in one more quiz question. Let's make it this. This is quiz question number 2, and I guess it'll have to be the last quiz question because I'm not going to take up your time to dream up 3 more. We'll just do one more. This will be a 2-question, 2-point quiz. What is the cubed root of 8? You need a number which, when multiplied by itself 3 times, gives an answer of 8. And I'll give you a hint. If you spell this number out, it starts with a T and ends with an O, and it has 3 letters, with a W in the middle. What number, when cubed, gives an answer of 8? Yes, it would be 2. Because 2 times 2 times 2, 3. 2 times 2 times 2 is 8. So the second and last quiz question, because I forgot the others, the second and last quiz question is 2. So again, you're going to want to send me an email titled Algebra 2A or Algebra 2B, Quiz 7-2, and you'll have answer number 1 is, what was it? Yeah, you know what it was. And answer number 2 is the answer to this. All right? So those are your 2 quiz questions. Like I said, the quiz is going to be super easy. designed not to check your understanding as much as to simply check and see that you are actually watching the videos. And please, don't send the answers to all your friends so they don't have to watch the video. What good is that going to do them, really? It gives them free points. Yeah, and then they don't have to see the videos and they don't know what's going on and they're learning nothing. So don't spread the answers around. Let them watch the video for themselves. Why are you doing all the work for them? Let them watch the video. No big deal. And they'll still feel so good about themselves. Oh yes, I watched the video and I got the quiz questions by myself. Yes, let them have that joy. All right, that's it. We're done. Thank you. Goodbye.